Hello folks, thanks for joining us today. So my name is Keith Keogh and I'm the lead VMware solution architect for the VDI Ready Solutions team in Dell. So our team were responsible for the VDI workload within Dell. And once again, I thank you for the opportunity for leaving me speak to you about implementing Horizon on VxRail. So today we were going to focus as well on 14G VxRail. So we'll mention 13G and 14G, but you know, big announcement this week that 14G VxRail is RTSing, so you know we'd make some time to feature on those. And also, you can rate the session by adding your feedback during the session or wait till the very end as well, and your feedback is very much appreciated. Okay, so here's the agenda. We're going to basically break it up into four sessions. So we're going to talk about the current trends, Horizon and VxRail, how they integrate together. Section 3 will be architecture and scaling, so we'll just go through some of the best practices with regard to scaling with Horizon and VxRail, and then the last section then we'll just go into a little bit about performance. So the VDI solutions team here in Dell, we actually validate these solutions from end to end for a VDI workload, so we'll give you some information on that and how we get those user density numbers. Okay, so let's look at the beginning, when it started. VDI become used within the enterprise. So typically there was one single user type. Take a call center worker, for example, which was desktop based, perhaps, that only had a handful of applications that didn't require dedicated machines or desks. The applications themselves are moved to VDI and then installed in each image and running on traditional infrastructure. As this was relatively simple, savings were made, service was delivered, but over time images would drift and maintenance would become more complex like the traditional desktop. So around 5 years ago, there was an increase in user types because the benefits of VDI has been understood. There was also realization that VDI was offered as a compelling security solution for the banking sector, for example, as well as IP protection for offshore development. However, running more use cases with more applications increased the complexity around maintaining the environment, which led to increased support issues and ultimately increased cost. So in addition, the demand for the infrastructure and in particular the storage increased, which that increased cost. And although specific solutions were in the marketplace to address some of these challenges, integration and management were still a big issue. So today things have even got more complex. So VDI is being used even to engage mobility. There's potential to use high-end graphics, which we'll talk a bit later on, and also to integrate modern applications, like from SaaS-based providers, as well as to host VDI sessions via DAS, so that's desktop as a service. So the user experience is hard to guarantee across all these scenarios, and it's hard to manage this increasingly complex stack. So let's look at the typical project lifecycle to deliver VDI, the concept through to implementation. Here's a high-level view of the lifecycle that calls out the common phases of a project of this nature. It's key to assess your environment before any detail is planned and have a key understanding of what you're centralizing and virtualizing and how long it's likely to take. So the results of this assessment will determine your support model and potentially bring different parts of the IT organization to structure and roll out. Whilst you plan and design, you also start to package your applications for VDI, while using traditional methods in an average of 1 per day. So that's the usual kind of time frame. To ensure the final solution is manageable and supportable, potential new operations are set in place, and then you're nearly for rollout. The pilot phase is used to stress the environment before deploying. So based on 1,000 users and 100 applications, the estimate we see is about 250 days. That's the project lifecycle. Now let's look at the technology stack. So as you can see, there's a lot of elements to the technology stack. It's great that it gives you the ability to have preferred vendors for different levels of the stack. But some things need to be considered when designing that platform. Will expertise be needed from each of the vendors just to install or support each platform? Your design might be bespoke and therefore unproven. So when it comes to difficult issues troubleshooting your environment, which vendor will take responsibility, or try and pawn it off as the other vendor's issue. So the good news is that there's a new approach, which we're basically talking about today. It's a bit of a delay there, apologies. So what we're going to do is we're going to build from the ground up. So network using your existing solution. If you have both internal and external users, you might consider using VMware's NSX, which segregates the users securely and runs them on the same platform. So NSX always gives you the ability to manage core network components through software, and then therefore you're no longer dependent on other teams and physical tasks. So you're truly virtualizing your data center. So VxRail is our the topic of discussion today with Horizon. So this enables you to deliver small increments, replacing traditional storage. So your compute and hypervisor configurations together in a linear scale. VxRail is built on VMware's hyper-converged software and delivered as an engineered appliance with an automated workflow to stand the environment up. This means that you can extend existing VMware skills, deliver fast and with more certainty. So Horizon 7 Enterprise, which is also part of what we're talking about today, is, this has been recently recognized as the leader in the IDC market scope for client virtualization. So desktop and application brokering is supported via Horizon and Horizon apps. App Volumes also is the primary application delivery tool, revolutionizing the lifecycle of the application in virtualized environments, cutting the time to package apps by 2/3, reducing image size by up to 80%, and providing tools for simple maintenance of the application. You may still need to isolate applications to overcome any potential application compatibility issues, and that's where TINAP may come in. So also, Y0 and TIN clients are industry-leading and most secure, and the endpoints then are optimized for both TCP and BLAST. So here we have now a radically simplified solution for the stack for VDI. That this gives all what you need to deliver multiple users in any location, consuming any application. You may now be thinking that this is already game-changing and very compelling, but we are not finished. So what other challenges of the management of this full stack? What happens if there's user downtime, for example? What happens if a hardware component fails? How do you plan for scale? So VROPS, which is vRealized Operations for Horizon, provides health and performance monitoring for virtual desktop applications. This is ultimately focused on providing a consistent and high-level user experience. So your IT admins are now empowered to provide more proactive, not just reactive, using simple dashboards to isolate and remediate issues, automating changes, and planning for future capacity. By what you need when you need it, and deliver incrementally infrastructure, which is the whole linear scale which we're trying to promote, is easy using this standardized approach. And but just, I suppose, a caveat to mention there with VROPS and something like the app stack is that there, an agent needs to be installed on the VM itself, so there will be a little bit of overhead on that. So just to be mindful of that when you're doing your sizing. So in summary, this is the simplest approach to plan, deliver, and manage the latest generation of virtual desktops and applications in your environment. So you're no longer designing and integrating multiple components from different vendors, planning and designing for far simpler, leveraging VxRail and infrastructure appliance. The application package process is cut by 2/3, and deployments can be accelerated. Okay. So now when we're looking at the entire lifecycle of planning, delivering, and supporting VDI, Horizon 7 and VxRail is the most compelling solution available today. Okay. So what we're going to talk about next, we're just going to have a look at the VxRail in a little more detail. So this week, what we've coming out is the 14th generation version of VxRail, and a little bit later on as well, we'll go through the life cycle of VxRail, where it started and where Dell EMC became, the part of the family as such. So it's the most efficient, low CPU and memory overhead. We have more direct I/O paths, so this is because of its kernel integration within vSAN. Full data efficiency services and per VM policies via vSAN also, and quality of service. So it's very flexible. You can configure it for any use case. We're going to specifically talk about VDI. You can start small and pay as you grow. That's the linear scale we've been talking about. So, recommendation is, minimum is 3, but we recommend 4 to start. And then, you can scale on a per node basis after that. So you have comprehensive data options, a broad set of availability profiles as well. And also with regards to integration, we can use existing VMware tools, We have flexibility with regards to vSphere licensing, and we also have an option of using an external virtual center. So when you deploy your VxRail infrastructure, each one comes with an internal virtual center, but there is an option to use an existing virtual center you may have in your infrastructure. But a point to note there is that the VxRail manager, the VM, there is an option to export that or use an existing one that would needs to be run from within the infrastructure. So the VxRail and the VMware stack. So we have three kind of topics here with regards the VxRail and VMware stack. So we have our hyper-converged software, deployment and support tools, and what's kind of the turnkey part of this appliance as well is that the other data protection options that come with this appliance that don't really come with any other product that's out there right now. So we have vCenter Enterprise, vCenter Server, vSphere Log Insight, and it's vSphere ready. So when you deploy your VxRail appliance, when your cluster is up and running, you have your vCenter up and running, you have your virtual center instance, whether it's on the actual cluster itself or it's an external one. And also you have vRealize Log Insight there as well that you can leverage or choose not to if you have something of some product that you're already using. So the development tools, and we'll speak a little bit about this later. We have VxRail Manager, an EMC secure remote support, and then with regards to data protection options, so recovery point for VMs, Cloud Array, vSphere data replication, and vSphere replication. So we're going to talk a little bit about solution layers. So we have 5 solution layers mentioned here. So we have the computer layer, we have the management layer, we have the storage layer, network layer, and the thin client layer. So essentially VxRail is giving your compute, your storage, and your management, all in one. Networking we've talked about, and we'll talk a little bit later on it about the traditional spine leaf configuration that's used and promoted within VxRail. But also we have the VMware product NXX we can layer on top of this, to give you that extra virtualization capability. And we have the Dell Wise thin clients options then as well for your way of connecting into your VDI infrastructure that's hosted on VxRail. And we'll talk a little bit later on about what kind of types of thin clients we will use. So the big promotion of VxRail obviously is the pre-installation validation, and we'll talk a little bit about our reference architectures as well later on, where we do it's a pre-validated we've validated the actual end-to-end configuration of VxRail with Horizon, and we produce density numbers on the back of that. So these you have peace of mind as well that this has been done in the factory. That it's not just a server that you need to layer software and hypervisors on top of it. This has been validated with all the mentioned VMware products. Okay, so this is the VxRail lifecycle. So you can see here from first came about in 3, and right now we're on 4.5. So it's been innovating at a rapid pace. We've been releasing new versions rapidly, and which adding new functionality and supporting new customer use cases. So since 2006, VxRail has added all-flash capability, which a suite of space-efficient features like inline deduplication, compression, and erasure coding, which comes with vSAN, and this lowers your dollar per IOPS and made all-flash HI solutions a realistic TCO play within the data center. So in late 2016, this was the first kind of product to be taking advantage of the Dell EMC acquisition. So it was the first product that showed the true capability of Dell EMC and VMware. So with PowerEdge, we are truly better together. With PowerEdge, we can offer tremendous amount of flexibility in the platforms and components of the platform. So even though at December of 2016, VxRail 4.0 was launched, there was still, for the entry level variant of that with the Q series, so the Quanta box was still available. But the V series and E series, which we're predominantly talking about on this call, is Dell product. And also to note as well, which isn't available on the with the first release of 14G VxRail, the VCE product is being replaced by the C series, the C6420. So that will be later RTS, but not right now. It's 14G, the V series and the E series we'll be talking about. Okay. So one thing to note there as well, you can see 4.5 was first launched in Q3. This is available on 13G and 14G. But on 13G, you have the option of 4.0 and 4.5. But with 14G, only 4.5 will be offered. Just to give you a little difference of what 4.0 and 4.5 the differences are. Obviously, the VxRail Manager version is different, but the underlying vSphere and vSAN. So 4.0 is ESXi 6.0 with vSAN 6.2, and VxRail 4.5 is ESXi 6.5 with vSAN 6.6. Okay, so we're going to talk a little bit about the VxRail Manager. So this is the primary deployment, an element manager interface which delivers automation, excuse me, lifecycle management and serviceability. So we can complete single-click upgrades via the VxRail Manager appliance, and we speak a little bit about that as well when we come to, your minimum requirement, why you would potentially go with, why you need to go with 4 nodes over 3, basically. So this GUI gives you it gives you monitoring via dashboards for health events and physical views. So you can see from the graphic there, you get you can drill down to even as far as what drives in particular slot, the health of each, and you can see all your cluster within that one pane of glass. And also within the marketplace option there as well, there's additional products you can download as well, like for Horizon Cloud on-premise would be an example of that as well. Also to mention, while we're talking about the manageability of VxRail, is ESRS. So that's secure remote services. So it's a highly secure two-way remote connection between your VxRail appliance product and Dell EMC technical support. So this also provides automated health checks to ensure your environment is at optimal performance with a remote issue analysis and diagnosis. Okay, so now what we're going to do is we're going to have a look at 14th generation VxRail. So you can see at this release you have V series, the P series, the S series, and the E series. So we don't have the Q series with release, so this will come in a later release, so that will be the C6420, which will be the replacement for the Quanta box. So it provides more flexibility to meet each use case. So you can see we have the VDI optimized V series, we have the performance optimized P series, we have the storage dense S series, and we have the E series. So the V series is the one we'll be kind of talking about, and the one we validated within our reference architecture, but we heavily promote the E series as well. So your E series would be your if you don't plan to use GPU or don't plan to use it in the future, well then the E series may be more suitable to you. One thing to note as well is that with the V series, you can see that we have new power supplies as well. So the big change from 13G to 14G is that we're moving from a 6x16 backplane variant, which was based on the PowerEdge R730, to the R740XC, which is a x24 backplane. So straight away more disks per server, and also with 14G as well, we have the ability to have 3 double-width GPU cards, which on 13G we only had 2. So you can see straight away, we have a more of a power requirement. So at release, the only available power supply will be the 2,000 watt power supply. So there's a 1,600 watt variant which you would use for the the P series, but then if you move down to the E series, we have the 1,100 watt, which was our maximum available for 13G. And just something to note there as well on GPUs, and we'll speak a little bit about that later on, is that and we'll talk about BOSS. So BOSS is the new replacement to SATA, and that with BOSS we are only able to have 3 M60s or 2 M10s. Because of the amount of GPUs that come with the M10s, we basically go over the threshold with BOSS of the amount of total I/O that can be handled with that server. So 2 M10s with BOSS boot and 3 M60s is the configuration. And that release as well, it'll be just NVIDIA GPUs. Okay. So this slide here just kind of gives you an overall picture of the options that are available. So you can see, you know, the new Intel Skylake processor as well. So we have 31 variants of that. So we go all from 4 to 56 per server. So that's, I think, the biggest amount of cores per CPU is 28. So that's a big jump from, I think we had 20 with 13G. And we'll talk a little bit later on about our configurations. We go with a 20 cores or higher in model. So the memory architecture has changed as well for 14G. So we've 24 DIMM slots, but we have 6 DIMMs per channel. So for a balanced configuration, you need to either have 12 slots populated or 24. And that will become more apparent when we talk a little bit about our configurations as well a little later on. So you can see here the variants we have with the power supply. So for the V series, which we'll be talking about predominantly, is 2000 watt. And then for the E series, would be 1100 watt. Storage options, which is new to 14G, is that there will be SATA-based disks available. So traditionally, we just had SAS-based SSDs, but now, you know, we'll have SATA options as well. Networking, so SPS or, you know, RJ45. So default 4 by 10 gigs, the Intel 7010s. That's a bit of a change from 13G, whereas, you know, we could have 2 by 10s or 2 by 10, 2 by 1s or 4 by 1s. And GPUs then NVIDIA. And something to note then as well with the GPUs, and this has always been the case really, is that from the factory, the GPU software, so the VIBs or the, you know, the additional software that's needed is not installed in the factory. So that's a post, you know, deployment configuration that's needed. So VxRail, so when the VxRail plug into your standardized VMware environments, it's because vSAN is the heart. So that's what we're, you know, is the underlying technology that we use for our software-defined storage. And we have a seamless integration with vSphere. Then, you know, it's kernel integration, and it offers the most compelling feature and high performance of any hyper-converged appliance out there, regardless of the underlying server. But we're obviously talking about VxRail here. There are some, you know, significant enhancements with vSAN 6.6. So that's why you're seeing a lot of these, you know, claims there of better performance with regards to IOPS and response times. So because there is security as much as well, vSAN now includes data arrest encryption, or DARE, also known as. So customers can choose VM level vSphere encryption or native HCI data arrest encryption through vSAN. So vSAN's version of DARE is native to HCI and is set at the cluster level for broad protection. Continue on the protection theme. There is now local site protection for stretched cluster support also. Something else to mention there as well that we'll not really discuss much in this presentation, but something to note as well is that, you know, there's support as well to Dell EMC VxRail. So that's the, you know, the file share products within Dell, but there's a virtual appliance version as well that will be optional via your marketplace as well. So there's going to be a single socket option as well, but within our configurations within the VDI Ready Solutions team, we promote dual socket configurations. That essentially, because since we're bound by CPU and memory, essentially, you know, that's where our bottleneck is. So if we reduce to one single socket, then our numbers reduce accordingly. So we're going to have a quick look at our V series. So for those who are familiar with VxRail, you know that the V570 or V470 13G variant, that's your hybrid option, and the V570F, V470F, that's your all-flash. So it's, you know, we can have a minimum of 1 or up to 3 double with PCIe GPUs. So that, if you have 3 double PCIe with GPUs, that would, you know, you wouldn't be able to have any additional PCIe cards except for that takes into effect as well that you have, you know, your HBA controller and your boss device, which is a PCIe card as well. But if you wanted to add in additional, you know, redundancy with regards, you know, not just using your NDC 4x10 gigabit options, well then, you know, you need to factor that in as well with your configuration, because if you plan to have 3 double width GPUs, you will not be able to do that. So as I mentioned previously, dual sockets up to 28 cores per CPU, so that's 56 in total. We can go up to 1.5 terabits memory configuration. So 768 is with GPU, and we'll see in our top configuration later on as well, 768 is our top configuration, because, you know, within a VDI use case with the processors we use, there's no point having, you know, 1.5 terabits of RAM if you're botting out at your CPU, and you could have potentially, you know, 700 plus gigs of RAM idling doing nothing. So that's why we do our validation, and we give the recommendations accordingly. So this configurations, we mentioned we have SAS and now SATA support coming in, and BOS as well. So with the BOS as well, and we'll speak a little bit about that in a while, you know, you have 2 by 240 gig SATA options, also 120 gig options there, but for VxRail, the only option there is 240 gig. So, you know, this is, I mentioned BOS, so this is boot optimized storage solutions for VxRail. So this is the, you know, the SATA DOM replacement. So SATA DOM was one device, you know, a bit more resilient in IDSDM with regards, but, you know, with IDSDM, you had 2 devices, so, you know, you had a mirroring option here. So with SATA DOM, it was essentially a single kind of, single point of failure. But with this, we've kind of negated that, because you have 2 you know, SATA devices which go up to as far as 240 gig, which can be configured in a RAID 1. So you can tolerate a failure there as well. So, you know, the BOS optimized solution comes in response to customer requests for simpler, you know, more economical way to segregate operating systems and data on server and storage. So many customers, particularly those in the HCI arena and those implementing software-defined storage, prefer to separate their operating system drives from data drives. You know, so and the actual internal drives we use within VxRail will be pass-through configuration for our vSAN. So, you know, with VxRail, you know, the IDSDN is also included in this, but that is used for your VxRail like factory tools. So you can do your factory reset and your other options via your IDSDN. So both are used. So what the PowerEdge team engineering developed a simple, cost-effective way of meeting customers' needs. So the BOS uses 1 or 2. So we're promoting 2 SATA devices instead of 2.5-inch SSD drives to boot the OS. The M2 devices offer the same performance as 2.5-inch SSD devices, and by consolidating the SSDs and controllers on a chip in a single PCIe adapter card, so we then free up additional drive slots for data needs. So BOS is available with all 14G servers, but and all the 14G VxRail appliances, and that will be the only boot option that's orderable within 14G VxRail. So for those that are using 13G VxRail, SATA DOM will be used, and 14G will be using the BOS option. So there's a slide in here just to, you know, VDI complete. So you see here on the left, which is the vSAN ready node, but we're going to talk here more about the VxRail on the right. So these, you know, is a way of, you know, bundling your hardware, your software, your Horizon, your vSAN, and getting a per dollar per user, you know, over a, you know, 36 months or 48 months term via DFS financing. This is 13G right now, so the 14G variant will be coming out. So VxRail obviously has just released for 14G, so that's why there's been a bit of delay. vSAN Ready Node has been out for, you know, a few months. So now we have both 13G or 14G vSAN Ready Node and VxRail 14G. So this will be updated to reflect the 14G numbers. Okay, so since we're talking VxRail with Horizon, we're just going to briefly kind of touch on vSAN. So, you know, vSAN is our underlying SDS technology, so it's software-defined storage fully integrated into vSphere. So we don't need a management VM as is needed by other vendors. So this is completely integrated into the kernel. So you have flash or magnetic disk options, that are pulled to create a shared data store. So we have hybrid and all flash. Storage policy as well can be assigned to VMs. So the storage, there's a default storage policy that comes with vSAN, and then when you deploy Horizon on top of that, there's 4 additional policies that come with that, depending on whether you're using floating, persistent, or depending on your use case. So that comes with the Horizon integration. Okay. So hybrid and all flash options. This comes with vSAN Ready Node as well, and so we have some customers still prefer the hybrid option. There's some challenges out there right now with regards to SSD availabilities, but the kind of the reason why a lot of people are going all flash, not just because of the performance, because with vSAN as well, you have your inline deduplication and compression, which does not come with the hybrid option. Okay, so networking. So you can see here, we're following the traditional leaf spine network architecture that is, traditional across all our HCI offerings. So it consists of 2 network tiers. So we have level 2 leaf and a level 3 spine based on 40 gig non-blocking switches. So mainly consistent performance, no throughput reduction, and static maximum of 3 hops for any node. So, tried and trusted network performance. And also we have the option here of leveraging or layering, I should say, NSX on top of this as well to give you that extra, microsegmentation option. Okay, so industry-leading thin clients from Dell. So we have secure, versatile, and powerful. So you can have your traditional kind of desktop-based, which is 3040, or a versatile all-in-one offering, or else your mobile version as well. And you can see with the previous slide on VDI Complete as well, as part of that, cost per month per user, there's additional option there of attaching your Wise thin client to that as well. So that's the best way for you to attach to your VDIs that are hosted on your infrastructure or VxRail infrastructure. So we're just going to go quickly through the architecture and scaling. So, what you can see here is a Horizon logical. So you'll see within our reference architectures as well that we follow the best practices from that have been designed by and put out there by VMware. So all the way from vSAN, which would, recommendations on flex space, etc., all the way to the broker. So this is what the Horizon logical architecture looks like. So you can see, instant clones as well, VMware Link Composers. So instant clones has been, released as 7.0, and a lot of people and customers have moved towards instant clones. So linked clones is becoming not as prominent as it was with regards to floating pools. With linked clones, you do not have the dependency, with instant clones, we do not have the composer. Capabilities, or we don't need composer, I should say, as you do with linked clones. So that straight away frees up a potential Microsoft license as well. And with instant clones as well, once you do that initial, the publishing or provisioning of your first bit of the pool, you can really deploy VMs at a very, very high rate. So it's twice as fast as linked clones. So there's all the aspects of within typical logical architecture. You say connection server, UEM, application pools. So Horizon Apps is used for that. So you can have session-based connections or published applications. So this is what Horizon Pod Block looks like. So as I mentioned, we followed the recommendations from VMware. So you can see everything is broken into blocks in a pod. So within a 2,000 user pod, you would have your connection server, your virtual center, everything within that to service your 2,000 users. And the recommendation then by VMware is that you move to another pod if you go to another 2,000 users, and that, so for example, if you had 10,000 users, that would be 5 2K pods. So at the end as well, we give the link to the VMware, reference architecture where they go into depth about this. But this is the, we follow this best practice within our reference architecture. So this image here is just to show the linear scale of VxRail. So those numbers there, the 550 or, that's depending on your VM size. So that would change depending on, your profile. So we have, a one CPU, 1 CPU 2 gig for our task, 2 CPU 3 gigs for our knowledge, and then our 2 CPU 4 gig for our power workers, and scale accordingly. So you can see the first one there is 4 nodes all the way up to 64. So 64 is the underlying, it's the maximum you can go within ESXi. So that's in that image that shows your linear scale. So your first 4 nodes, must be the same, and then you can change once you go past that all the way up to 64 nodes. So you can see there are some rules there. All nodes in the cluster must run the same version. So there is potential to have different versions of hardware, but you need to be on the same. So it's all 4.0 or all 4.5. You can't mix. Other point to note as well, no mixing of hybrid and all flash. Needs to be either hybrid or all flash. 1 gig is supported, but it's something we don't really promote. I think with all our infrastructure or all our reference architectures, it's everything is predominantly 10 gig. So the first 4 nodes must be identical as well. Flexibility. So all appliances models in a cluster do not need to match, as I mentioned. We can have variants of CPU, although we would recommend, if possible, to keep everything the same. And 3 to 64 nodes per cluster, but max of 8 if it's 1 gig. Okay, so as we mentioned previously, 3 nodes is the minimum, supported configuration, but 4 nodes is something that we promote. So you can see, FTT equals 1 is your default policy. So we don't need 3 nodes. That's your only option. If you wanted erasure coding or inline duplication, you would need more than 3 nodes. You don't have that with 3 nodes. So when a node fails, there's no additional node for to rebuild. So although it can function and work on 2 nodes, not ideal, and then unprotected maintenance. So, when performing maintenance, only 1 copy of data is available. So what we'll do is we'll talk a little bit about 4 nodes and how that works best. So 4 nodes provides full protection when a node is lost. So Virtualization can tolerate a complete failure of 1 node. And also, which is a big, this is one of the promotions, and how we promote this as a turnkey appliance for within our solutions, is that, you have potential one-click upgrade of your infrastructure. So you can go from 4.0 to 4.5, but that's not an option if you don't have the 4th node. So this is the rolling upgrade reference that you see in that screen. Okay. So performance results. So we're going to, what you can see here as well is that on the left here we show the Dell EMC VxRail for Horizon. That's the 13G version. So this week we have the 14G version that's coming out, and then we have the VMware Enterprise Edition reference architecture. So those, go hand in hand as such. We follow their best practices, and we configure, we validate the Dell EMC VxRail appliance from end to end with Horizon within our reference architecture. All that information is contained within that document. Okay, so you can see here, Login VSI. This is it's the de facto industry standard tool for testing VDI environments, and even for server-based computing, published applications. So what it does, it installs a standard collection of desktop applications on each VDI desktop, and then it uses like a launcher infrastructure then to load the number of sessions against that. So you can see, 3 workloads that we predominantly look at is task, knowledge, and power. Task, very light user, knowledge, your medium kind of office user, and then power would be your kind of heavy user as such within a VDI environment. Okay, so some information here around our configuration. So you can see, task worker, 1 CPU, 2 gigs of RAM, but we reserve 1 gig of memory. Screen resolution as well is something to note, and that's something that definitely has a knock-on effect of your performance. If you deploy a VDI infrastructure out of the box, it may be set at 800 by 600, but that's not, a real-life user scenario. 800 by 600, would not give a good user experience. So we've change our screen resolutions accordingly. So we go with 1280 by 720 for our entry-level workload. We go with 1920 by 1080 then for our knowledge and our power. So we saw within our testing as well that step up from 800 by 600 to those was like a 10 to 15% hit on your user density. So it's pretty sizable. And the same can be said for operating system as well. So when we moved from Windows 7 to Windows 10, we saw a hit in our performance. And especially from, Office 2010 to 2013 to 16, there's a huge density increase in that. So when we moved to our, the ML midlife kicker CPUs there last year, all the performance gain we got with those processors was negated with this, worthwhile exercise of moving up to these new, software technologies was just something to note. So this is, I know we're coming close here to time, guys. So I just, we're finishing up in the last few slides. So these three configurations transcend across all our HCI offerings within the VDI Ready Solutions team. So you can see an A3, a B5, and a C7. So A3 would be your low starter kit. Excuse me. B5 would be your medium user, and C7 then would be your high end. So this, from a 13G to 14G perspective, this hasn't really changed much with regards CPU core. So we're still using a 10-core processor for our A3, our B5 for our 14 core for our B5, 20 core for our C7. But what has changed, as you can see there, our RAM has changed considerably. That's because the architecture has changed for 14G. So to get a balanced config, you either have to have 12 or 24 slots populated. With 13G, we could, step up in increments of 4, but now we need to go with the, since we have 6 DIMMs per channel. So our entry level has changed from 256 to 192 gigs. Our medium level has stayed the same, but there's been a pretty sizable jump on our C7 as well. So that jumps from 512 gigs to 768 gigs of RAM. But essentially, since CPU core is our limiting factor within the VDI testing environment, our VDI user densities have not really changed. They're identical essentially because we stayed with the same amount of CPU cores. But what the big plus with, which we'll talk about in the next slide as well, with the addition of the third GPU card, you have the additional GPU users per host, which was not possible on 13G. So you can see here are some of our user density information, and this is per compute host basis. So you can see that we can have 240 task users per server, but to note there as well is that the soft limit for vSAN is 200. So even though that really only comes into play when you scale up to 64 nodes, which we will not do because we followed a Horizon pod block methodology, we still just put that in there that even when we're sizing, we will scale in increments of 200 users, even though we know we can get more than 200 per server. And also here, the last two guys there, we have the M61Q, which is your 1 gig frame buffer. So 48 available on 3 double-width M60 cards, and then the M61Q, which is also a 1 gig frame buffer profile, which you can get 64 across 2 M10s. Okay. So all these task, knowledge, and power worker, this is the testing that we use across all our appliances. Horizon, we're at 7.3.2, and you can see there as well, if those of you are familiar with our previous reference architectures, you can see that we've moved to instant clones, almost 100% now, and we've migrated from linked clones. Okay. So some additional resources here as well. So, that link here brings you to the Horizon VxRail reference architectures. Also links here to the VMware Enterprise reference architecture, which promotes the pod block Horizon best practices. And also the last one there is Horizon 7 multi-site reference architecture, which has been recently updated as well. Okay, guys, that's essentially all the slides that we wanted to cover. So what I can do now is I can have a quick look at what questions are from the audience. So I just step through them. Okay, so you can how can kernel level integration enhance GPU performance with lower resource RAM comparing to normal desktops? Well, I suppose kernel level integration doesn't really give us GPU performance. What it does do is that, once we have the GPU cards installed, obviously, depending on your workload and the amount that's being offloaded, it will, lessen the amount of host CPU resource utilization. We do see a drop in the amount of, IOPS that has been used when we, offload everything onto the GPU card. But I suppose what's to note there as well is that, with our configurations, we only scratch the surface with the I/O capability of our configurations because we are GPU bound. And to note as well is, with regards to GPU as well, we follow the guidelines that are and profiles that are dictated by NVIDIA. So that's something to make note of there as well. Yeah. Okay, thanks very much. That's, yeah. So if I heard you correctly, you said deployments can be federated. I presume that's in reference to the pod block architecture. So I'll try to answer that one. So, what the recommendation is there is that, even though we have actually tested with a different kind of infrastructure, we've managed to get 6,000 users off one virtual center, and it worked fine. The bottleneck for the pod block architecture was the 2,000 sessions that can be only serviced by your connection server. So that's where essentially that's where our the kind of federated pod block model comes from. So the recommendation, even though potentially you may be able to get past that 2,000 users, the recommendation is to stick within those guidelines. And I believe that's probably going to change soon as well with the newer versions of Horizon. So we're on 7.3.2 right now. So whether that changes with 7.4 that's coming next month or 7.5, that's that will be information that will be given to us by VMware. But within our testing as well, we would probably recommend, to definitely move to a new cluster, even though after 2,000 users, just for kind of best practices, HA capability. Thanks. Okay, is there any other questions, folks? I don't see any other questions from the audience. So, any other questions, guys? We still have, a few minutes left, 13 minutes left. Let me jump back to slide 4. Excuse me. Yes, does every pod require a separate vCenter connection server? That's recommendation, yes. But as I've mentioned, we have proved that potentially one vCenter can service up to 6,000 sessions. That goes beyond their recommendation. So they recommend that every 2,000 users you have a unique vCenter connection server. Next generation GPUs. So the P series P40 is coming out that we will be looking at in the new year. I think it's going to be supported on VxRail in February. So that will be the P40. So that's there's 28 gigs frame buffer potentially available. So I think the maximum we go within the M60 and the M10 is an 8 gig frame buffer profile. But with this card, we can potentially go up to 28 gigs. So that may be when it comes to 3D virtualization, which we haven't done a lot of testing on ourselves, because we try to aim towards more traditional VDI use cases where kind of your standard office space Windows 10 configuration. So, you know, if you want to contact me directly on that, we can definitely let you know when those they're called those new NVIDIA P series card, so the Pascal card. So Tesla would have been the M series, and Pascal is the new series. No, it is not possible to use SD cards for boot. So your SD cards are actually, when you buy a VxRail appliance, you actually get your SD cards as well as your, you know, your BOS configuration for 14G, or, you know, your SATA on. They actually, you know, as part of the factory install process, that that factory reset tool is installed on your SD card as well, so that there is an option just to have that install alone is for your boot. Okay, so there is what we'd recommend. There is a VxRail size tooler, but we're updating it right now for VDI. So you know it covers a lot of you know, other use cases. But what we would recommend, if someone is trying to size a VDI environment, to basically point them towards a reference architecture. And although that doesn't cover, you know, every scenario that's out there, but you know we can definitely help you along. But when that update has been made to the VxRail sizer, we will definitely let you guys know. It doesn't. No. So the question there is, how does the limitation of 2,000 connections per pod affect VxRail cluster? It doesn't. Yeah. In a you know real ideal world scenario, we can scale up to 64 nodes, which is essentially our ESXi mode. That's correct. But we're following the best practices from Horizon. So there's other products out there that can potentially scale past that, but this is what we'd recommend. So I suppose to answer that question again, it doesn't affect your cluster limits, but it's just, you can potentially scale to 64 nodes. It's just that your broker may not support that, essentially. And that's what we're talking about on this call here, is the Horizon integration with VxRail. So, best practice recommendation, 2,000 connections per pod block, which potentially will change in the new year, but right now that's what it is. Okay, folks, we have about 8 minutes left, so feel free to ask more questions there, if you like. So I suppose to mention as well, the current version of Horizon, we're at 7.3.2. So that since we've moved to Horizon 7, with each kind of dot release, there hasn't been, there's additional functionality been supported within, each version. But with regards to user densities, it hasn't really impacted the amount of users we can get per server. And same as well to mention with 14G. So we're promoting, exact kind of user density configuration from 13G to 14G. But something to note as well is that what we've done as well is that we traditionally we would have had an 85% cutoff of standard CPU, but with the Intel Turbo capabilities which we enabled within our VxRail appliances, with our B5 configuration, we can potentially go up to 120% of CPU with Turbo feature enabled. But the thing about it is that we cannot see that once ESXi doesn't have the capability of showing plus 100% utilization. So what we do is we test to 99% because we know once we go to 100%, we cannot see how much further we go past 100%. But you can see, even going from 85% traditional CPU to 99%, with factoring Turbo into the equation, the amount of users we can get has increased But you may prefer to go with your 85% traditional model, because a lot of customers out there, don't understand what turbo brings us, or would not like the size based on turbo. The procedure to upgrade each. So it's possible to, depending on your version of, I think it's, and you'll get that from the Dell EMC support site. Depending on your version of 4.0, you need to get to a certain version of 4.0 before you can go to 4.5. And there's definitely a procedure on how to do that on the support website. But to note there as well is that we need your fourth node. So if you have a standard 3-node cluster, which is the minimum support, which you don't recommend, well then you will not be able to do that. So also, what kind of an upstream network configuration would be ideal for a knowledge worker or VDI design with 2 CPUs and 2 gigs of RAM on each VM? That's a slight bit different to our configurations, but it's slightly in between our task and our knowledge worker. We design a 10 gig. We promote a 10 gig design as such, but you can see if you look at our test section within our reference architectures, like within our configurations of a 3-node or 4-node cluster, we don't come anywhere near 1 gig of total throughput on that cluster, and that's so everything is split out logically. So we can configure all of your across 2 10 gig NICs, or you can go to 4 10 gig NICs. But it's an option. 4 10 gigs NICs would become more apparent when you're scaling out, but it's quite manageable to do with 2 10 gig NICs once you segment all your VLANs off logically with VLANs. But it is possible with 1 gig, but you're limited with the amount of nodes you can go to within the cluster with 1 gig as well. So 10 gig is what we promote, and 25 gig coming down the track as well, but not supported at this moment in time. Mike Mooney will help any customers. Yeah, I know Mike, so yeah, he's very, very helpful guy. As I said, as part of any questions that come out of this presentation, feel free to to reach out to me. I can if we can't answer you on this webinar, we can help you, and even with regards to documentation, if you need pointing in the right direction of where the documentations are, I can definitely help you with that. But until that sizing tool has been updated, we would recommend for VDI use cases that people follow the reference architectures, because that has been validated from end to end from a VDI perspective. Yes, correct. 3-node is a minimum requirement. It's coming from vCEN, correct, yeah. Although there is 2-node options as well. You have your robo / configurations where you have a third virtualized ESXi, VM as your witness node, but with we haven't validated anything of that configuration with vCEN or even with VxRail, but 3 nodes is the minimum, yeah, but 4-node recommended. Coming from the underlying vCEN, correct. So folks, 2 minutes left, so if you want to get those last questions in while we have time. And also, if you want to use the 2 minutes as well, guys, to leave some feedback. Any feedback is very important to us, and how we can potentially improve these webinars for you guys. And we're coming to the last minute, and I'd really like to thank you guys for your time. I know your time is very valuable, and for giving me an opportunity to speak about Horizon with VxRail on 14G. So 13G still supported, but 14G RTS in this week for VxRail. And thanks very much. Okay, I think we have one last question here. Okay, yeah, have a great day, guys. Thanks very much.